So friends, today we'll discuss the preparation and reactions of alkene as well as conjugated time. So we'll discuss one by one various preparation methods. First method is dehydration of alcohol. Second, dehydrohalogenation of alkyl halide. Third, dehalogenation of vicinal dihalide. Fourth, control hydrogenation of alkynes. And last one, cracking of alkanes. Dehydration means removal of water molecule to form alkene. Dehydrohalogenation means hydrogen plus halogen from the alkyl halide will be removed to form alkene. Then dehalogenation of vicinal dihalide. Vicinal dihalide means the chlorine atoms will be present at the two carbon atom. One is present at first and second. So vicinal dihalide means adjacent carbon atom. Then control hydrogenation of alkynes, that is acetylene to form acetylene or the ethene. Then last one, cracking. Cracking means heating of alkane at high temperature will get the alkene. So these are the preparation methods. We'll discuss one by one. First one, dehydration of alcohol. So we have taken this alcohol and mentioned this OH group and CH group in that way. If we are treating alcohol with the H2SO4 at the heat, so OH and H liberated as water molecule, and this will produce the bond between the carbon and carbon. This will produce alkene. When we have taken one propanol or propanol treated with the sulfuric acid, the water molecule removed to form propene. So this is the dehydration of alcohol. Then second, dehydrohalogenation of alkyl halides. So I have taken alkyl halides treated with the NaOH in alcohol. H and X will be removed to form alkene, and water and HX is the byproduct. HX is the byproduct. Water means if we are treating with the NaOH in alcohol to form water. So propyl chloride we have taken, and then we have treated with the NaOH in alcohol to form propene and HCl. Then we will discuss the dehydrohalogenation of alkyl halide, that is saytzeff rule. If the dehydrohalogenation of alkyl halides can yield more than one alkene, according to the saytzeff rule, main product is highly saturated alkene. We will take the one example. When 2-bromobutane is heated with the alcohol KOH, it will produce 80% 2-butane and 20% 1-butane. So we have how saytzeff rule will be followed. Initially 2-bromobutane is treated with the KOH or NaOH, and when we are treating with the KOH in water molecule, hydrogen will be removed. This will produce primary carbocation, and again KBr or Br will be removed to form 1-butane. So formation of primary carbocation, it is less stable. When we have treated 2-bromobutane with the KOH, a removal of the hydrogen atom from this will produce secondary carbocation, and secondary carbocation is more stable, and again removal of the bromine atom from this to form 2-butane, and 2-butane is the stable product, and we are getting 80% 2-butane. So that is the saytzeff rule. Means formation of secondary carbocation leads to formation of stable product or high yield product. Formation of primary cation leads to production of lesser product or less stable product. That is the saytzeff rule. Then cationic rearrangement reaction or carbocation rearrangement reaction. When we have taken the alkyl halides, suppose this is the alkyl halide 2-chloro-3,3,4 trimethylpentane, then we have treated with the H2SO4, and it will get the 2,3,4 trimethylpentane. So removal of these to form double bond in between these, and removal of these to form migration of CH3 group to this removal of Cl group leads to migration of this towards this and formation of double bond in between this, that is called as carbocatene realignment reaction. So we have taken mechanism also. This is the starting material. We have treated with H2SO4. So from this chlorine is going to remove to form secondary carbocatene, and this secondary carbocatene again reorganized, means migration of CH3 group towards this to form tertiary carbocatene. Secondary carbocatene converted into tertiary carbocatene, and then removal of hydrogen atom to form bond between these to form 2,3-trimethyl pentene 2-ene, that is the carbocatene rearrangement. And third method, dehalogenation of vicinal dihalide. Vicinal dihalide means adjacent carbon atom has the dibromo compound or dichloro compound. So this is the vicinal dihalide. Vicinal dihalide treated with the zinc in ethanol. So ZnBr2 will be removed, and this will produce the double bond between these, that is alkene. When we have taken one example, 1,2-tribropane treated with the zinc in ethanol, and we will get the propane and ZnBr2 zinc bromide. That is dehalogenation of vicinal dihalide. And fourth, control hydrogenation of alkyne. So this is the alkyne. We have treated with the nickel at 250 to 300 degrees centigrade at hydrogen. So hydrogen is going to add to these and here to form alkene. We have taken methyl acetylene treated with the nickel, and we'll get the propene. We'll get the propene, not ethene. Propene is the product. Then fifth one, pyrolysis or cracking. Decomposition of compound by heat, that is called as pyrolysis, and process is applied to the alkane, that is called as cracking. When larger alkanes are broken into mixture, lower molecular weight alkanes like alkenes and hydrogen. So this is the ethane heated at 500 degrees centigrade, absence of air. So to form ethene initially, 2 molecules of methane and hydrogen liberated. So these are the preparations method for the alkene. Then we will discuss the reactions of alkene. First reaction, addition of hydrogen, halides, HBr, HI, HCl. Then second reaction, addition of hypohalous acid, that is HOCl. And third, addition of sulfuric acid. Fourth, addition of water. Sixth, addition of halogens. Next, addition of hydrogen. Catalytic oxidation. Oxidation with potassium permanganate. Ozonolysis. Polymerization. And last one, oxymercuration and demercuration of alkenes. So we will discuss one by one. So first reaction, first 5 reaction or 6th reaction is related with the electrophilic addition reaction. Electrophilic addition reaction in the sense addition of H and Br that leads to the formation of alkyl halide. So I discussed electrophilic addition reaction. Alkenes contain carbon-carbon double bond, to which treatment with the hydrogen halides. Initially addition of hydrogen atom, that is called as electrophile, to form carbocatene, and carbocatene attacked by nucleophile, that is halide, to form addition product. That addition reaction is called as electrophilic addition reaction. We'll discuss ionization of HBr to form H plus and Br minus ion, and then this alkene added the hydrogen atom and it will produce carbocatene, and again Br is added to this to form alkyl halide. So one example, ethene treated with the HBr and it will produce ethyl bromide. 2 butane, so H goes to there and Br goes to there to form 2-bromobutane. Alkanes are treated with the hydrogen halide HCl, Br, HI to form alkyl halides. Ethylene treated with the HBr to form ethyl bromide. 2-butane treated with the HBr to form 2-bromobutane. Then Markovnikov rule for the addition of hydrogen halides. If alkane is unsymmetrical, H of HX goes to the double bonded carbon atom that has already greatest number of hydrogens. So I have one example, propene. So hydrogen goes to there and chlorine goes to there to form 2-chloropropane. Then next, addition of hypohalous acid means HOCl. This is the ethene treated with the HOCl, OH and Cl. So initially ionize Cl plus and OH minus ion. Then OH goes to there and Cl goes to there. Electrophile is attached to the double bonded carbon atom which has highest number of hydrogen atom. So product is ethylene chlorohydrin. Ethylene treated with the HOCl, OH goes to there, Cl goes to there to form ethylene chlorohydrin. Then if you are treating propene, OH goes to the double bonded carbon atom which has lesser hydrogen atom. Cl, that is electrophile, goes to the double bonded carbon atom which has the greatest number of hydrogen atom to form propylene chlorohydrin. Mechanism: ionization of OH and HOCl to form Cl plus and OH minus ion. Initial addition of H, addition of Cl to form secondary carbon and addition of OH to this to form 2-chloropropanol. Then third one, addition of sulfuric acid. When the sulfuric acid treated with the alkene to form alkyl hydrogen sulfate. So this is the propene and sulfuric acid, HSO3H, H goes to there, OSO3H goes to there to form alkene sulfonic acid. Initial ionization of sulfuric acid to form H plus and OSO3H. Initial addition of hydrogen here and OSO3H to form isopropyl hydrogen sulfate. So this is the addition of hydrogen sulfuric acid. For the addition of water, water adds to alkene in presence of catalyst to form alcohol. So this is the propane. H goes to there, OH goes to there to form 2-propanol. Mechanism: ionization, H plus and OH minus ion. H goes to there to form this, OH attaches to form 2-propanol. Fifth one, halogenation of alkenes. When alkene treated with the halogen in presence of sodium chloride to form dihalogenated alkane. So this is the ethene. Chlorine goes to there and there to form 1,2-dichloroethane. Sixth method, addition of hydrogens. So this is the alkene. 2 hydrogens will be added here and here to form alkane. The propane, simple addition of hydrogen, add this and this to form propane, and reducing agent is nickel. Catalytic hydrogen oxidation. Catalytic oxidation means we are using catalyst like silver and we are performing oxidation. So ethylene undergoes oxidation in presence of silver to form ethylene oxide. Then next method, oxidation with the KMnO4, means we are treating the ethylene with the KMnO4 in presence of NaOH and it will produce ethene 1,2-diol. Then ozonolysis. Ozonolysis means we are treating with the ozone and zinc oxide. Initially ozone passed through the solution of alkene in inner solvent, that is chloroform or carbon tetrachloride at low temperature. So it will react by addition of across to the carbon-carbon double bond of the alkene to form more ozonide, and again which is spontaneously isomerizes to form ozonide, and ozonide decomposes in presence of zinc to form carbonyl compound, that is aldehyde. I discuss the mechanism. So O2 is going to convert it into O3 by HV fusion and then we'll have the ethylene treated with the ozone. So this group attaches to there to form 1 2 3 trioxalone, then breaking between these to form CH2O OA CH2O. Then this will attaches to this, this will attaches to this to form ozonide. Then treatment with the zinc oxide will be liberated. One goes to there and one oxygen goes to there to form formaldehyde and zinc oxide. Ozonolysis. Polymerization reaction means simple addition. Ethylene treated at the 200 degrees centigrade at pressure 500 to 3000, and we'll get the polyethylene. And last one, oxymercuration and demercuration. When the ethylene treated with the mercuric acetate, and we'll have the various reaction. So propene treated with the mercuric acetate, so mercuric group will be added to this and OH group added to this, and then reduction of this here will be an addition of hydrogen to form 2-propanol. That is the oxymercuration and demercuration of alkene. We have taken mechanism. Propylene treated with the mercuric acetate, HGOAC will be attached to this, and then HNOOC minus. So is migrated towards it, this will produce, and H goes to there to form acetic acid. And then reduction means removal of this to form propanol. Then we'll discuss the dienes or conjugated dienes. We'll discuss 3 types of dienes: isolated, conjugated, and cumulated diene. So definition of dienes means unsaturated hydrocarbon containing 2 double bonds are called as diene. There are 3 types of dienes: isolated, conjugated, and cumulated. Isolated means double bonds are separated by more than one single bond. Conjugated diene means double bonds are separated by single covalent bond only. And cumulated diene means double bonds are adjacent to each other. So cumulated diene means double bonds are very adjacent to each other. Conjugated diene means double bonds are separated by single covalent bond, and isolated diene means double bonds are separated by the 2 single covalent bond. That is the various class. Then we will see the preparation of conjugated diene. So first compound that is conjugated diene is 1,3-butadiene. 1 and 3 position will have the double, and it is separated by the single covalent bond. That's why we are calling conjugated diene. Example 1,3-butadiene. Various preparation methods are there, from the acetylene, from the 1-butene, from the 1,4-butanediol and butane. So acetylene treated with the NH4Cl and CuCl, that is Lindelar catalyst, and then we will have the vinyl acetylene again treated with the Lindelar catalyst to form 1,3-butadiene and 1-butene. It is addition of HBr. Here the hydrogen is going to remove and Br is going to add to form this intermediate, and KBr liberated Br and Br and H will be liberated to form 1,3-butadiene. Then next method 1,4-butanediol. So dehydration to form 1,3-butadiene. Butane. Dehydrogenation means removal of the hydrogen. This to form 1,3-butadiene. These are the preparation methods for the dienes. Then diacetyl reaction. 1,3-butadiene treated with the ethylene. Simply addition reaction to form cyclohexene. Then electrophilic addition of conjugated diene. Dienes are treated with the hydrogen halides to undergoes 1,2 and 1,4 addition. So this is the diene, conjugated diene, 1,3-butadiene treated with the HBr. If hydrogen goes to there and Br, if hydrogen goes to there, it will produce positive charge at the second, is more stable. In addition of bromine at the second position to form 2-bromobutene, it is less stable product. If the intermediate is more stable, product is less stable. It is inverse case in the alkene. Then 1,3-butadiene treated with HBr. If H goes to there, and positive charge will make there an addition of Br to form 1-bromobutene. So this is the less chance or more stable product. This is the one example we have taken. Dienes are treated with the hydrogen halides to undergoes 1,2 addition and 1,4 addition. So 1,3-butadiene treated with HBr to form secondary carbonate. It is more stable. In addition of Br to this 2-bromobutene, and this 1,3-butadiene again treated with HBr. An addition of H here and positive charge will be observed here. It is less stable. An addition of Br to this to form 1-bromobutene. It is more stable product. Percentage chances is 80%. This is the electrophilic addition reaction, also called as addition of hydrogen halides to the conjugated diene. Then second, addition of halogens. Conjugated dienes are treated with the Br2. Simply Br is attached there, one position and second position to form 3,4-dibromobutene, and 1 and 4th position, 1 and 4th position to form 1,4-dibromobutene. Addition of water of 1,2 addition to form butane 3OL. H goes to there, OH goes to there. If H goes to there, it will produce more stable carbonate, and OH attaches to there to form butane, but1ene 3OL. It is less chances of product. If you are treating H2O, H goes to there and positive charge at the primary, it is less stable. Addition of OH to form butanol, it is good product, or low percentage chances for the product is higher. Then addition of hydrogens to addition to form butane, 1-butane, and 1,4 addition to form 2-butane. Hydrogen goes to there and there to form 2-butane, and hydrogen goes to here and here to form 1-butane. So major chances for the product is 2-butane, less chances for the formation of product is 1-butane. Why? Because 1,2 addition gives more stable product, or more stable intermediate gives less stable product. 1,4 addition gives less stable intermediate and more stable product. So this is the concept. In polymerization, 1,3-butadiene polymerizes in presence of peroxide to give polybutadiene. So this is the 1,3-butadiene undergoes polymerization in presence of peroxide. Then free radical addition reaction. Simply HBr is going to form H and Br. Initially Br is going to attract it towards this to form more stable intermediate, and then H is going to attach to this to form less stable product, that is 4-bromobutene. Then again treatment of H. If Br goes to there, and dot charges will be observed there, and addition of hydrogen to there to form more favored product, 1-bromobutane. That is free radical addition reaction. Then allylic rearrangement reaction. Allylic compound means the functional group or functional group is present at the beta to the olefinic linkage or alpha to the olefinic linkage. Functional group is present alpha to the olefinic linkage. So this is the olefinic linkage and this is the alpha carbon atom, and to that alpha carbon atom OH group is there. OH is the functional group, that's why we are calling allylic compound. And then rearrangement of allylic compound, that is called as allylic rearrangement reaction. So allylic compounds are those compounds which has the functional group which are alpha to the olefinic bond, that is called as allylic compound. And allylic compound undergoes acid or base catalyzed migration to form new compound. We'll have one example. So this is the allylic compound treated with the acid. OH will be liberated water molecule, and OH again migrated towards this, and carbon double bond shifted to this to form this compound. Okay, we'll have the mechanism or one example also. So but 2ene 1OL treated with the acid to form but 3ene 2OL. We'll have the mechanism also. But 2ene 1OL treated with the acid HNOH to form positive charge, and because of the positive charge double bond is shifted to this, and positive charge will be acquired at this location, and attachment of OH group to there to form but 3ene 2OL. Then last point, stability of alkenes. So tetrasubstituted alkenes are more stable than the tri, di and monosubstituted alkenes because the effect of hyperconjugation. In case of disubstituted, trans form is more stable than the cis form because more substitution leads to more conjugation. More conjugation is directly proportional to the stability. Hence, tetrasubstituted alkenes are more stable than the di and monosubstituted. Then less stable isomers have the higher energy, and which is identified by the heat of hydrogenation. We'll have the one example. Cis-butene and trans-2-butene will be treated with the hydrogen in presence of nickel. Addition of hydrogen to produce energy, that is 28.6 for the cis-butene, and addition of hydrogen to the trans-2-butene to produce butane and energy 27.6. So as comparative study, cis-butene on hydrogenation gives 28.6 energy, and trans-2-butene gives energy is 27.6. So lesser energy will be produced by the trans-2-butene. Less energy indicates compound is more stable. High energy indicates compound is less stable. So this is the stability of alkenes if you are considering the hyperconjugation effect and heat of hydrogenation. So tetrasubstituted alkenes are more stable because the effect of hyperconjugation. Hyperconjugation means number of alpha hydrogen present at the alpha carbon atom. So number of alpha carbon atoms are in tetrasubstituted like 4. That's why it is more substituted, hence more stable compound. Stability of conjugated diene. Then we will discuss stability of conjugated diene in terms of two concepts are there. First one is resonance stabilization and second one is heat of hydrogenation. Initially we will discuss the heat of hydrogenation. 1,3-butadiene, and it is isolated diene treated with the hydrogen in presence of nickel. Simply addition of hydrogen to form 1-butene. Addition goes to here and here, and it will produce 1-butene. 1-butene, and it will produce the energy minus 57.6, and isolated diene on hydrogenation to form 1-pentene, and energy is minus 60.8. So which compound liberates high energy? Isolated diene. Hence those compound which liberates high energy, that compounds are unstable. In case of 1,3-butadiene, it yields lesser energy, that is 57.6, hence it is more stable. Then resonance stabilization. So 1,3-butadiene undergoes resonance stabilization, means positive charge at this and at this, it will produce. Then same, this will undergoes vice versa reaction, means negative charge at this and positive charge at this, to produce resonance effect. As more resonance effect, compound is more stable, hence 1,3-butadiene undergoes resonance structure, hence it is more stable. Thank you very much for watching my video. Please subscribe my channel, also watch and like my videos. Okay, thank you very much.